Okay, so after the YouTube video, there's one more question. It says calculate the residual of the 0.545. Did the LSRL, or the least square regression line, over or underestimate the value of y, and explain? Okay, so this one's gonna be a little harder. So basically the first thing that you have to do is, you remember the equation, this one? This is the LSRL. So it's saying calculate the residual of the 0.545. So you're basically going to use these two numbers and plug them into the equation. Well, actually, it's only going to be x because you're trying to find the predicted y. Okay, so you're going to get the formula right here, and then you're just going to plug in your x. And so then your y hat is going to equal negative 8.263. And then that's your least square regression line. So basically what this is saying, it's like your predicted y value. Because remember, if we look at what it means, it's your predicted value, right? Okay, so that's the first part. Next, you have to use this formula, which is r equals a minus p, which is residual is equal to the actual minus predicted. So the actual number is 5. That one's your y. Remember, this one's y hat, so that's predicted. This one's your actual value, like the actual answer. So you're trying to find r, which is your residual. Residual basically means how far, like what's the difference between the two numbers. So what is the amount that it was wrong by. So you're gonna do r equals a minus p. So the actual one we said was 5. So you're gonna do 5, and you're gonna do minus, and then we got, for the predicted y, we got negative 8.263. So you're gonna do minus negative 8.263. You subtract those, you get r equals 13.263. So if you want like a visual, this is what I did. So this line, this line that I made right here, that's your LSRL, least square regression line. This point on the line is this one. This one's your predicted one, right? So that's on this line. But then your actual one was 5. So I put it right here since this was negative and this was 5, right? And then what we calculated here is the difference. So how far apart it ended up actually being. So that's how you do that. So you use, so remember, this is your predicted, this is your actual number, and this is how far apart, they are. So, and then it says did the LSRL, this line and this point, did it over or underestimate the actual value of y? Explain. So remember, we said that the actual value of y was 5 and the predicted was negative 8.263. And we said that the LSRL, or the predicted, it underestimated. Okay, so now we have to explain it in context, right? So I said the LSRL, remember it's this line and this point, underestimated the actual value of y, and then I put in parentheses 5 squirrels per plot by 13.263, which is the difference. And then I said the estimated value of y was negative 8.263. So that's how you explain it in context. Okay, so now I'm going to explain like how I knew what to write. So for E, or yeah, E. So this one was describe it. So this one we said that we're going to use Duff's, right? So if you go into your chapter 3 packet, this is lesson 3.1. So this is what it was, right? That's where I got the first one. Okay, and then for B, remember we had to talk about the correlation coefficient, or R. So in lesson 3.2, we talked about it here. So we said the linear relationship between x and y. Remember, I just plugged in the x and the y, so I did percent of trees and squirrels. And then remember we figured out that it was strong because it was 0.842. And then the direction was, well, we see in the scatter plot that they gave us, it's going down. So we also said that it was decreasing and linear. So you have to kind of memorize like this. You just have to plug in the x, the y, talk about if it's strong or weak or moderate, and then you have to explain the direction with context. And then that's what we did for B. Okay, next we also did D. This one's the one that you need to memorize. I wrote it a little differently on my test, but she didn't mark it as wrong. But she told us to write it like this. So the percent of the variation y explained by the linear relationship with x. So for that one, instead of saying that, I remember we had the r squared. I said approximately 70.9%, which remember over here we do the percentage, of the squirrels per plot is explained by the linear relationship of percent of trees harvested, which is x. So you use this one to do r squared. Okay, and then for the slope one, if we go into the packet and we go to 3.3, this one's also how to find the residual and the prediction for f, but we went over that. So for this one, we're talking about how to write it, right? This is slope. So basically we're saying, remember we did this, for every additional squirrel, there are 0.135% of trees harvested. So for each additional, and then you do x, here we said percent of trees harvested, because remember that was our x. The predicted, I just said there are 1.135% of trees harvested, but you could say the predicted, and then you add y, which is squirrels per plot, and then you say increases or decreases. Remember we say it decreases by, and then the slope, which is 0.135% of trees harvested. Units is just context.